All right, let's look at some problems from 5 where we're going to describe the complement of a given event, find the probability of the complement, and then look at case. So give the complement of the event. When 6 job applicants are tested, at least one of them test positive. You can think of the complement as the opposite. So if we want to find the complement that at least one of them tests positive, the complement would be none of them test positive. So it's the opposite. Find the complement when 9 cameras are received, none of them are defective. Well, here you might think the complement is all of them are defective, but the opposite of any. So at least one is defective would be the complement. If a couple plans to have 3 children, what is the probability that there will be at least one girl? Complement to work problems like this because at least one girl is the same as the complement of all boys. So in other words, the complement would be at least one girl, the probability equals 1 minus they had all boys. The probability they had all boys. What's the probability of having a boy? 1/2. The second one, 1/2. The third one, 1/2. And this and take 1 minus 1/2 times 1/2 times 1/2, which is 1/8, and get my probability. So notice that when you're doing a complement, if I said at least one girl, the complement would be 1 minus no girls. So that's where I get the all boys. It's just a faster way sometimes to find probabilities. All right, the data represents the results for a test for a certain disease. Assume one individual from the group is randomly selected. Find the probability of getting someone who tests positive given that he or she did not have the disease. The word given is what makes it a conditional property. So what you're looking for is the probability the test is positive given they did not have the disease. So what I do is I write my conditional probability formula out, which says the top, the numerator, is the and of probability test positive and did not have the disease, and the bottom is the probability of the given part. The probability they test positive and they did not have the disease, positive, did not have the disease, 18, divided by the probability they did not have the disease, which would be the sum of these two values, is where I get the 159, and I finally get my probability.